Jessalyn. So hey everyone, let me pull up some screen here. So welcome to the talk on test abstraction layers, which I've kind of titled How to Avoid Overcomplicating Your Tests. But this is a useful talk, I think, for maybe people who have undercomplicated their tests and also want to learn some abstraction to maybe make them a little bit nicer to work with. One slide too many. Who am I? I'm Shane Gearon. I'm an automation engineer. I've been doing quality and automation engineering for about 10 years now. In Vancouver, worked at Quickmobile, Hootsuite, and now at Slack, along with a couple of other companies there as well. And I started off sort of doing manual mobile testing, moved into automation, then into web automation, and now I'm doing API testing at Slack. So what's this talk about? This talk about is understanding the different layers of abstraction that are used in testing. And I'm sure like anyone who has been doing automation for a little while or has used any of the different automation tools will already be using these, but maybe they don't understand exactly what they are or where the different layers of them are and how many of them maybe that they're using without even knowing it. And so it's sort of like going to go through where and how to use them and how you can build sort of a more sustainable automation framework or testing in general. So the areas I'm going to cover, I'm going to just quickly cover abstraction layers, let you know what I'm talking about when I mean abstraction layers, go into test frameworks, and so how you can like pick the right test framework for what you need to do. Application abstraction, so that's building abstraction around your application to make it more testable. And then execution abstraction, which is wrappers around how you run and execute the tests that you're writing, all these different automation pieces. And then I'm going to go through a couple of stories to like bring it all together and some examples of places where I've gone wrong and the team that I've worked on has also gone wrong. And then I'll save some time at the end for questions. So let's dig into it. Abstraction layers. So what do I mean by this? What is an abstraction? So abstraction is just sort of wrapping one piece in something else to basically separate out the concerns of two different things. So you've got a thing that's doing a lot of complicated stuff. You can abstract that out and have maybe a simple wrapper around it that can call that more complicated function in a way that's easier for people to interact with. And so that could be something in your test scripts. It could be a tool that you run that does the abstraction for you, that makes something easier. And a common example is kind of like working with a test framework itself. Maybe it's a web test framework. And instead of you having to code the clicks to click on and how to find elements and all of that, it's got functions built in that kind of abstract all that complexity away for you. So how do they help? So abstraction layers help by making things a lot easier to work with. So it can simplify things, it can make them nicer to use, it can make you avoid repeating your code in a lot of cases. Instead of having the same thing happen over and over and over again, you can just use an abstraction layer to just call something maybe quick and simple. It makes code concepts easier to use and to understand a little bit sometimes. Like maybe you don't know the complexity that's behind it, but you don't need to know it, and that's a good thing. And it can allow work to be broken up into multiple parts as well. So maybe one team works on the execution of the tests and one team works on the writing of the tests. Having those abstraction layers so both teams don't have to understand both things can be a good thing too. So when should you not use abstraction layers? And so I think the key to this talk is like going through all the different types of abstraction and making sure that you're not using too many, or that the ones you are using, you're using them in a maintainable way. The troubles that a lot of testing teams get into is that they build up these abstractions upon abstractions upon abstractions, and then it gets to the point where people don't actually understand. They're like, yeah, the tests are running. And then when they break, they're like, I don't know what it's doing. I don't know how it does the thing that it does. And so trying to avoid making work harder for you, whether it's debugging or refactoring tests or even replacing the test framework in the future. So let's go through some examples to maybe dig a bit more into this. So test frameworks. When you're picking a test framework to use, which is it's a layer of abstraction, right? You're taking some actions, whether it's moving things in a mobile device or whether it's making HTTP calls easier, whatever it is, it's an abstraction layer around that functionality. You need to kind of make a decision as to which type of framework you want to be using. And so some common decision drivers are like who's going to be both writing these tests and running them? Is it going to be a quality team writing and a development team running? Do you need to make it understandable by both teams? Are their developers just going to keep hitting rerun because the debugging messages aren't something that they're able to understand, or it's something that they know how to work with? Using tooling that's familiar with you, or do you use tooling that's familiar with the rest of the team? Language choice can come into this too. Like, do you pick a language that the back-end team uses or the front-end team uses, or do you pick a third language that is good? And then another thing that comes up a lot is sort of that open source free option, where a lot of teams will opt to that because you don't need budget approval or something like that. But maybe that's not always the right choice too. So what can go wrong? Like we're going to pick the best tool for maybe one group, and sometimes it's the best tool for you if you're the decision maker, or if it's a smaller team. You can pick the tool that's best for you, and then it becomes your job to make sure it works all of the time, and no one else in the organization wants to help you because you made choices that are not compatible with what they're used to. Maybe you pick something that's too simple and it can't do all of the things that you need because you didn't have that technical depth to understand it. Or maybe you went the opposite direction and you pick something too complex, and then there are junior members or intermediate members on your team that are unable to work with it because there's too many moving pieces and they don't understand the concepts. So you're never going to get like the magic framework that does everything, but it's important to like take these things into account. And there's no magic bullet that's just going to be like, here's the framework that does everything exactly as you want. Well, actually, there kind of is. So you built your own framework, because if you build it, it can do everything that everybody wants all of the time. If you want to in the chat, I'll check later, own up to this. I know I've done it, and I'll get into that later. So you build your own custom framework that does everything that every different person wants. But now what have you got to do? You've got to build out training on how to use this new tool because there's nothing available already. Documentation is really important because you've implemented it in a custom way that only this organization uses. You're now the bottleneck on the team because, hey, if anyone needs to update something in it, they're probably going to come and ask you because you're the one who built it. And sometimes, quite often, I guess, it'll be replaced when subject experts leave. So if you've built this custom framework all by yourself and then you leave the company and a new quality person comes in, they're just going to rebuild it because they don't want to take the time to understand all of this custom stuff unless you've done everything above really well. So what should we do? So I think some of the best practices are like looking at the most standard framework first. There's all these different testing frameworks out there, and some of them are really, really popular. If there's a really popular test framework and it can't do what you need to do, is it something wrong with the test framework, or is it something wrong with the way that you're thinking about the application or thinking about testing in general? Because if there's thousands of people using it, it's probably doing a lot of things right. Making that decision, like I said earlier, depending on all the people, like who's going to be debugging, who's going to be running the tests, who's going to be writing the tests, and make sure it's easy for everyone there. Implement it as simple as you can. Follow the tooling guides. If you're using a test framework and your tests look exactly like the example, you can just point people to say, hey, go to the test framework example page and write a test exactly like that and use the official documentation of this framework, and you'll be fine. Keep an open mind for sure. Like, don't just go with the tool that you've always used because that's the way that you've always done it. Keep an open mind, look at what other frameworks there are out there, speak to other teams, find out maybe if they're using something as well. I see it very often, people like a different framework on every team. That's not as maintainable. And then the last piece of advice is just don't name it. Use terms that are Googleable. Even if you're like wrapping a standard framework in your own thing and you want to like put a name on it, by doing that, you're saying, oh, hey, this is the Shane automation tool. If I type that into Google, I'm not going to get any results. And then everyone's going to come to me and ask me for help on that. So where possible, yeah, don't put a name on it, call it what it is. It's like, if this is a Selenium framework, hey, say, hey, this is our Selenium testing framework, link to the Selenium docs right at the beginning of the like README in the repo. Tell everybody exactly what tooling it's using. Like, we use Node.js, it works on this version. Like, make sure everyone knows exactly what they're getting into when they're using your tooling. Right, so that's about test frameworks. So the next thing is application abstraction. So you can, that's kind of wrapping something around the application to make testing easier. And some common examples of this, which I'm sure everyone's heard of, are page objects and helper functions. So page objects is this idea of, this is in web browser testing, where you have a web page, and traditionally a web page would be kind of a static thing with like maybe a header section and a footer section and a main body. And you could take all those components and wrap them in an abstraction layer, which is called page object, that says, hey, we're defining this piece and this piece and this piece. And then in your test, you can just pick which piece you want to do. So I want to click on something in the header, so header dot whatever, and click on that element. And then if someone goes ahead and updates and changes the selectors on you, you can go and update just the page object and not the rest of the test. So this is like a good example there. And then helper functions are doing a similar thing. They're wrapping some kind of common thing that you're doing. Maybe it's a login, maybe it's a search for a thing, maybe it's go to a page, and wrapping them in a function that you can just call one line function rather than having to like go through the individual clicks. So here's an example. I'm using Nightwatch.js here. It's a web browser framework. You don't really need to know too much about it. The main thing is just showing that in this test, we're doing everything hard-coded. Google.ca, we're going and finding a form with an action. We're sending keys to that. We're sending the enter key, and we're asserting that there's an element called this with the text value that we're looking for. And then so with page object model, we can now go, and instead of doing that, we can do homepage. We're defining homepage at the top as our page. And then we have some before and after that's navigating to the homepage. And then we're setting a value and doing a submit. So that's kind of wrapping those elements so they're a little bit easier and maybe nicer to work with. But maybe someone's already seeing a problem here. We had a one file test, and now we have this, and then we have the search page and the results page. We have 3 tests. So we're adding layers of complexity, and that's what it is. It's a balancing act. When you add abstraction, you've got to balance the complexity with the value that you get back out of it. So page object model, we've taken something that was fairly simple and made it a bit more complex, but what do we get out of it? We're getting something that's more maintainable. There's only one place that I need to update my selectors, update my URLs. Everything will just continue to work. Don't have to touch all of the tests. It's easily extendable. I can add new stuff onto it and build it out. And it's, in a lot of cases, it's a lot more readable too. Like some of those selectors, you don't really know what it is. It kind of goes very deep and long selectors. You can make them more readable and give them like friendly names as well. So when wouldn't you want to use page objects? So sometimes people will go too far with page objects, and they'll create a model of the whole page, even sections that you're never going to write a test for, or maybe you'll write one in the future, so you're just going to do everything. And that's just technical debt. It's dead code a lot of the time. Single page application. So maybe you're trying to force a complexity when it doesn't quite fit your use case. So a lot of the apps, web apps that we use these days are single page applications. They have ambiguous page boundaries. Is this the same page? Is everything one page? Do I have multiple object models? Do I have one big one that's hierarchical and digs all the way down between all the elements? So make sure it fits your use case when you're adding this, and don't just do it for the sake of doing it. And maybe your implementation is too complex, and maybe finding the element that's getting called, I have to click through 4 different files to find where it's actually defined. And maybe that's slowing down debugging efforts. And then similarly, helper functions. So here's an example of the previous test. We took page model and then we whacked a helper function because there was 2 lines. It was like entering a thing and submitting a thing. So I've just wrapped that in a Google.search here for Nightwatch.js to make a helper function around it that's simple and easy. And then every time I need to do a search, I can just call the Google.search, right? Much easier. Um, but then you have sort of similar problems with helper functions. And this is something that I've kind of seen a little bit when they get overused. So login as admin user with SSO after password reset, like that's a big mouthful. I don't really know what it does. Like maybe the person who wrote it knows what it does, but do I use this in my test? Do I write another one with an equally verbose long name? Makes it kind of confusing. Do I do like in the second example here and have parameters that I'm passing into my login function of user type admin SSO true? You can do that and it'll make it easier. And then everyone's just using the same login function. But now you have conditional logic inside of your tests, and that can break. Do you need to write unit tests around your helper functions now to ensure that when someone changes it, it doesn't break all of the tests because you've accidentally flipped a conditional one way when it's supposed to be the other? So good helper functions should be reusable across multiple tests, not have too many options, variables, avoid that conditional logic, have documentation. You can write documentation in the like docs above the function in the comments there. You can write documentation in readmes. You can have it in a Word doc that you print out and staple to everyone's desk. But have somewhere where people can go and read up exactly what the helper functions do and how they're supposed to be used. And try and be as clear as you can with their purpose. And so these are inside the test framework, all of these different ways of adding another abstraction inside of the framework that you're using. What if we added something outside the tests? And that's where we get this thing. I was finding it hard to find a name for it. I called it test-specific application code. But it's usually used as a method for speeding up tests, and it's custom application code, usually an API if we're talking about web applications, that you can call to do a bunch of functions without having to go the long way around and use the UI. And so that's like, can I have a function that I just call an API and it creates a user in the database for me and then gives me back the username and password, and then I can just log in right away instead of having to go through a sign up flow. And maybe there's a helper function for signing in as well that just sends me back a session token. And so these are APIs that you're not going to release to the public. They're not going to be shared with everyone, but they're useful in your test because, hey, I don't have to do the sign up. I don't have to do the login. My test can start right away with that session token and just blaze through it. And we've got a really helpful abstraction there. So these shortcut functions, once again, finding it hard to name it. I named it a couple of different things. They're great for encouraging like best practices, like separating your test from your setup. You'll probably do a lot more documentation around these because they usually live inside the application code. So maybe there's more code reviews, more strict unit testing. People are better at maintaining it. It could be usable across multiple frameworks too, as well as manual testing. So if you had an API that creates users, there's nothing stopping you from making a nice little command line tool that manual testers can use to create users when they need them as well. And it's communication back and forth between developers and testers, because you've got this thing that's living in the application code that's not for the customer use case. It's not part of the application for that, but it is part of the application helping the testing portion. And so it's this nice little link between the people writing the code itself and the testing teams, if you have that as a setup. And then, yeah, you can gain a lot of the most useful reason of it is like that performance gain that you can have. So these shortcut functions, these testing APIs are super useful. And so here's just an example of what it might look like. So I've created a function in my test that now just does a fetch call to example.com API create user that's hopefully not available to everyone, just available to testers. Usually you want to have a token or some kind of header that you pass in to make sure that people can't call this and make free accounts on the internet. But yeah, just check the response get back and then pull that data out. And maybe that data's got that username and password and maybe the account ID and that kind of thing. So you're probably seeing a pattern here, like there's an abstraction, super useful, well done. When don't we use it? So once again, this is something that you're maintaining, but now it's even potentially something that you're not maintaining. The development team might be maintaining it. If it's implemented poorly, it can make it much harder to debug the tests. When you get failures, is it a failure in your like test code? Is it a failure in the application code? Or now is it a failure in the shortcut function code or the test API code? And from my experience, a lot of the time there are issues with using these, like create user functions and login functions, because they're never going to be built to production standards. Unfortunately, that it's not customer facing. It's not a high priority. If it fails 1 in 10 times, that's maybe an acceptable error margin, because it is only used by the testing team. And so sometimes they're under provisioned as well, and which is, it's kind of a weird case where it's like these APIs won't have as much resources dedicated to them, but then also they're probably going to be used a lot more, especially if you're creating a user in every test, for example. So it's finding a balancing act where you can have like solid, stable versions of testing APIs versus the speed gains that you're gaining from them. So maybe it's worth it, maybe it's not. Cool. Looks like I'm going okay for time. This is the last section before I get to the stories and examples. So thanks everyone for staying with me on this. The last one's execution abstraction. And so essentially what this is how you run your tests. So one of the main reasons behind doing this is scaling tests out, maybe doing parallelization to get your test runs to be under a certain amount of time. But you're going to need some kind of tooling to do this, or you're going to have to build some sort of layer around the test. Most test frameworks are just designed to run the test like one at a time. Some of them have some parallel stuff built in, but even then, if it gets too many for a single machine, you want to split it across multiple machines. So the most common example I see of this is something like a CI pipeline. Jenkins is probably the most popular example. People will either love it or hate it. And so you can build a pipeline, and you can see here we've got sort of a build that happens, and then we've got some unit tests running, and then we've got some browser tests running, and then we do some kind of deployment. So it's a nice way to be able to split those tests up and make it easy to work with. This is the abstraction layer on top of it that makes it user-friendly. But then maybe it starts getting a bit more complicated. Maybe we try and over optimize a little bit. We end up with a pipeline maybe like this, where for some reason this bottom branch is running 2 things and the top branches are only running 1, and then we skipped a step in the middle. But maybe sometimes we don't skip it, sometimes we do. What's the logic that decides that? Where did that come from? It's important for this, especially if it's a critical part of your infrastructure, to be simple enough for everyone to understand, or well documented and shared out enough that everyone knows exactly how it works. So why don't make your pipeline? Why not to make your pipeline too complex? If you can't explain how it's working in sort of if it's in less than 5 minutes, if you can't say exactly what it's doing, maybe you've got a problem there. Does every team member that gets onboarded onto the team learn this whole system? How long does it take people to really understand the different pieces? Do you have you wrapped too many tools and other scripts? For example, do you have a shell script that calls Python with a bunch of environment variables that then actually starts executing multiple Docker containers, which are running Node, that have a custom Node library that's up on your own private NPM server, that actually ends up just downloading a shell script from another repo that you didn't even know existed just to run your JavaScript tests? Is that a real example? Maybe. Probably. Bigger companies that have a full team dedicated to something like a CI pipeline can take on the challenge of having these super optimized custom caching layers, super fast conditional test runs, depending on which files were changed in your PR. But if you don't have the resources to maintain something like that, you might be better off not building that, or at least building it in a way that's easy enough for everyone to understand. Final example for an execution abstraction, containers. Everyone loves containers. So most commonly Docker. Docker is going to give you something that's great for testing, a consistent runtime. So like if I'm running a container with the exact hash that you're running, we both have the same libraries installed. We're both using the same version of Python or Ruby or whatever it is you need for your testing. It can be used locally. I can just pull the container locally and run it, and then it runs the same container on CI. And so even though I'm on Mac and it's on Linux, we're like using the same system there. It's good for parallelizing things. You can use tools like Kubernetes if you want to get super crazy. Once again, more complexity, maybe avoid it, but you can parallelize things a lot easier once they're inside containers. When should you not use containers? One of the key like turning points I feel with the use of containers is when people build their own custom Docker image. And it's fine to have whatever, say you're running a tool, maybe Cypress or something, and then you pull their official Cypress image and you add like your execution script or something, like copy 1 or 2 files. I'm talking about like full custom images that have multiple different libraries that inject all of the tests into the container, that are maybe pulling like different parts of your application code in as well because they need them. If you start to do things like this and over optimize and try and have that container that starts off in like 0.0001 seconds, but has its own CI pipeline in order to build it that gets run half an hour before your tests, then maybe it's getting a little bit too complex. Do you need to update it every time tests change? Do you have to update the container whenever there's vulnerabilities, which means you need to do some kind of security scanning on these containers that you're using as well? It's an extra step to debug when issues need to get resolved. Maybe a library mismatch is in one of the containers. Then you have to do a rollback and roll back all of your testing to use a previous version of the container, or fix forward and wait for the container deploy pipeline. And then where are these custom images being stored? If it's got custom code in it, you're likely going to want it inside of a private repository behind a firewall. That's extra infrastructure to maintain. Can you check that out on your local machine? Do you have the right keys? That's another process. So all of these like different things slowly build and build and build. And quite often you don't realize you're there until you're there. And I've been there, where I'm like, oh, I have this custom image that I need to be able to pull, but these machines are running on a different infrastructure that doesn't have the right access to the repository that I'm pushing the images to. And now I have to talk to the security team. So it seems like you're doing all the right things, but eventually you get to a point where things have gone too complex. And so that brings me to sort of the final thing, my experience and what I've seen. So I'm going to give you a couple of examples and maybe a little bit more depth, and I'll answer any questions about it at the end. So the first one is creating an abstraction library. So we sort of had this idea of like, hey, we should follow really good development practices. A common thing with public APIs is you have a language binding for that API. So you're like, oh yeah, I have a JavaScript SDK for accessing the public endpoints of Slack, for example. We have that. If you want to use that, let me know. So why not for our testing APIs have something similar with our own framework? And so what we were meant to do, we have all of the API endpoints mapped as functions that you could call. You would import the library, and then you'd have all the functions there and ready. They'd be documented, maintained. Your IDE, you could just hover over it and see exactly what parameters each of the API endpoints took. If you put the wrong parameters in, it would highlight and tell you. Oh, so good. We could share it across multiple test repos too. So if other test frameworks are using the same language, they can just import our library and then have access to all of these wrappers around all of the API functions and call them and make it super easy. What it ended up meaning is the backend team adds a new API endpoint, which happens fairly often in API testing. We'd then have to go and update our library, add the new API endpoint in, a lot of copy paste code, a lot of like rushing to get it out. We'd have to build and push a new version. Once again, private repository, because these are not public endpoints now. There's some internal testing endpoints. So we're keeping it in a private repository. Then we go back to our test repository, bump the version of the library that we're importing, and then do an install to pull it down. And now we can start writing our test. And wouldn't it be easier if you could just have a new API added and then just write the test? And so the problems we have with this approach is there was a disconnect between those adding the APIs and those writing the test. So someone would add a new API that we'd want to use, then the people writing the test would have to do this additional work. The wrapper didn't really add anything in the end because we didn't really go to the trouble of making it super verbose, because a lot of the time we just passed args through in the order that they were given. We didn't properly document it and have all the different parameters. A lot of the testing APIs that we're building stuff on top of, they didn't have documentation either because they're internal and no one in the public's going to need them. So they didn't have a proper API doc site like we would with all of our public APIs. Only one test repo ended up using it. Hey, we built for the big, like, grandiose use case, and it never eventuated when we could have saved a lot of time and just built it for the one we had. And it was just painful for everyone to use. So how did we fix it? We just deleted all that. We ended up getting rid of the library. We ended up bringing all of the code that we would, and similar to the helper function I showed earlier, just have all of that live with the tests in the testing repo. For the most part, we even removed the wrapper functions around all of our APIs and just took the API endpoint as a string input so that you didn't even have to touch any of the helper functions if you were writing a really simple test that just hit an API and checked the response. There's a lot of work that we're still gonna do, but we're trying to be like more obvious and not hide anything. So one of the things that when we're trying to get developers to write API tests, they were like, well, what are these functions doing? How do I find them? Like, how do I know exactly what's happening when I call create user? Whereas if it's like the new version, it's basically a call to post with the parameter test.create user or whatever it is. It's easy for them to go, oh, I know what those concepts are. I know what a post is, a HTTP post, and I know that endpoint because it's easy to work with. And so for both the quality team and the developers, like debugging and writing tests became a lot easier. One more quick example, because I feel like I've been going for like half an hour now. Building your own test framework. So I alluded to it earlier. Even if it's like mostly open source work, as soon as you put a name on it, you kind of own it. Why did we do this? So we found a problem. We had static test data, multiple tests were running. If they failed halfway through, or if people ran tests in a buggy state against the data, it left it in a bad state, we'd have to go and manually fix that data. But then a lot of those tests required a third-party service, third-party accounts, like, to create them. So we couldn't easily go ahead and just create as many as we want on the fly in the tests. And then the testing framework we were using was written by someone else who had left the company, and we didn't really understand how that worked either. And so it was kind of this perfect storm of, hey, we really need to do some testing. Let's rally around this. Let's build our own thing. We'll give it a name. It'll be great. It'll be fun. But what we ended up doing is we kind of built it in isolation of dev and other quality members. It was like, our team's the one building this and we're going to make it the best thing ever. And we'll just, if problems come up, we'll just make sure that we're on top of it. We tried to optimize around the best user experience over simplicity. So we added a lot of helper functions, a lot of additional tooling, a lot of additional layers. We designed something that was way too complex for what we really needed at the time. We had test data that was in a good state, that was like saved in a backend somewhere, and then we had console as a key value store, and we did locking on it. And when you grabbed a certain user account with a third-party account tied to it, then you would like get that and then use it, and then it would go through a cleanup function. And then once the cleanup function was complete successfully, it would unlock the resource and allow it to be used by other tests. We had all these like different layers, different tooling, different complexities, and no one really understood how it worked. And every time it would break, it was just kind of something we'd have to solve. And so how do we kind of get there? The tribal knowledge gets lost. Like people leave. Like once the core members who'd built that framework was started leaving, it became harder and harder. Anything that breaks is often rewritten. We'd done that when we built the framework, so I know for a fact that they're now rebuilding it again because they don't understand this particular framework, because we made it too complex for people to easily just get without doing a lot of work. Sometimes it's even worse. Tools that are just working are kept around and just wrapped in something else. And so it's like, oh yeah, like the example I gave earlier, where it's like, oh, well, these tests run and they're in a container and we run it, and if it gives a pass, we just call it a day. And then as soon as it breaks, you just kind of disable those tests because you don't really want to go to the trouble of fixing them. So yeah, that's kind of the way that I went about this talk, is like all of these different examples of where we've made things too complex, too hard to understand. We haven't built it in a way that's going to be maintainable going forward, and eventually it just gets to a point where it's too much. So with that, closing remarks. Layers of complexity. By adding any kind of abstraction layer to your tests, you should really know the maintenance costs that you're going to pay. A lot of teams are going to spend that time writing tests and building frameworks and building these abstraction layers, and then not allocate any time to maintain it going forward, because you're on to the next thing, or that's done and it's working now, so we're never going to have to touch it again. And so your tests should be as complex, and your testing frameworks and your tooling should be as complex as you have time to maintain them. So in summary, kind of what are we looking for? Do it the simplest way first, get something working, make sure everyone understands it. Use the tooling how it's intended. Don't try and customize everything too much, because it would be so much better if it did it this way. Don't build your own version of Jenkins plugins that do things in the way that you like it. Don't like go ahead and build your own testing framework. Set clear ownership and keep it clear within the teams who's going to be able to fix what, and where possible, make it so that anyone can fix something, so that you're not the roadblock there. Remove the complexities and consolidate where it makes sense. So like, just because you build something complex and it's great, if the maintenance cost gets too much, roll it back. Do what we did with the API library. Like, acknowledge that it was a great idea, you learned a bunch, get rid of it, replace it with something that works. And the most important thing is the least experienced team members and the people who are using it the most need to be able to understand the process as much as possible and be able to contribute as well. Yeah. So with that, what didn't I get to? There's so many different abstractions you can add. I only covered a few of them that I've had a lot of experience with, but you have things like test reporting, test metrics, test run auditing for whether you've got an audit process, just to make sure you ran all of the tests against every release that goes out. Project automation, like talking to your tooling, whether it's Project Board or Jira or whatever it is, like moving tickets around and that kind of flow, emailing people when releases come. There's all of these different abstractions that you can build. And I think a lot of this advice applies to all of that. Just like build it as if you're going to have to maintain it forever, and you're not going to have that much time to do it, and try to involve the whole team as much as you can. I think, yeah, that's it. So I'll just show the thanks slide. And I'll get to questions afterwards. My LinkedIn's up there. If you add me, just mention you're from VanQ, so I don't confuse you with a recruiter and reject you. And a special thanks to Jesse and Eric, who helped me put these slides together and this presentation. And the rest is crediting SlidesGo, because I stole the template from them, and I'm a nice guy and I credit them. And stop presenting.
Awesome. Thank you so much, Shane. I could see from a lot of smiles and nods and laughs throughout the presentation that I think a lot of people can relate to some of the things that you've shared. So that's really great. Yeah, so if there's any questions from the group, feel free to either raise your hand and you can unmute and ask it aloud, or if you're more comfortable, you can pop your questions in the chat as well. Or also, if you want to share a similar horror story, that's cool too. So we have Nikolay.
Yeah, Shane, thank you so much. Those were interesting stories, and it was good to know them. My kind of takeaway message from your presentation is, instead avoid abstraction layers and thinking twice before making complication to the code and to the tests and frameworks. So yeah, no, thank you so much. It's not really a question. It's rather, I see that you rather discourage us from using abstraction layers in most cases, which probably is a good idea just due to the maintenance of it. Yeah.
Yeah, I think I tried to have, and I started off with all of the good things, and there are good things, and you should use them. Like, I'm not saying you can't use a test framework, but yeah, I wanted to point out that all of the teams that I've worked with, one of the main problems is just using too many different things on top of each other and making things more complex than they need to be. And when I sort of pared it back, I was like, yeah, we're just doing too much abstraction, or all of the different abstractions, we're taking them to the extreme. Yeah, so cool. I'm glad you got something out of it at least. And that was the general message. Like, don't make things too complicated. Make it easy for yourself.
Yeah, I think that's probably a good rule to live by for everyone. Jen, unmute and ask your question.
Yes, first, thank you so much for your presentation. It was pretty good. I just have a quick question. So, like I mentioned about like a text from text abstraction within like text factory or text report, or even like a UI testing, for example, if they get to involve into the part of the developer team or their repository, and would you mind be able to have a more specific example about how it works and how the abstraction could be like maybe for example for the UI testing framework stuff?
Yeah, so I think it was a little bit hard to hear that, but I think the question is around like what's a good example of like maybe a good case to use abstraction for a UI on browser testing? Is that what you're kind of asking?
Yeah, pretty much. Also, maybe not just about the UI, because it's like a testing is kind of a flow. It include like a beginning source start from the UI testing, and later will generate test report, and then also the part of the thing that you mentioned. It will kind of the email to the people who should be noticed after the test finished. So it's like an entire process and how the abstraction layer could works within this kind of the different process.
Yeah, so I think like the core of the talk is kind of around, hey, don't make things too complex. And so if you're talking about things like that, like if you're looking at UI frameworks for doing UI testing, find the standard framework, try and make it work for you, try out a couple of them. Don't try and add too much custom code at the beginning, get something stable and working. Be clear with the team what you're using and say, hey, this is the problem that we're trying to solve. This is the tool. Here's all the documentation around it. Like hopefully it's provided by the tool that you're using. And so I think that the same applies if you're doing something like email automation as well. Like there are a lot of email automation tools out there. Can you use one of those? Can you use an external thing, maybe like Zapier or like if this then that, like maybe one of those tools that are already well used. And if someone does run into problems with it, they can Google. I think the key is like, can I Google the error that I'm getting back? And if it's an error that is a well-used error from a tool that you're using, you're probably going to get a lot of results back and people can unblock themselves. Whereas if it's a custom tool that you've built yourself, the error that's going to get back is something that you've written. And even if they find something on Google, it's not going to be about the thing that you're talking about. And so it then pushes it back on you to actually help that person out and maintain the tool. And that's not scalable long term. So yeah, just pick the standard tooling and wherever you need to do any kind of customization, just be aware of it, I think is the key. It's like, hey, I couldn't find anything. We really need this. This is super important to us. Let's allocate a time to do it, like to build it out. Let's make sure a team owns it so that if it breaks, there's someone there that can maintain it. And let's train everybody on it so that when you leave the company, someone else can take that over and doesn't have to go through that whole process again of rebuilding the tool because they don't understand how it works. And also don't put tools under your personal email and then leave the company, and then no one can log into the admin of the tool. That's another thing that comes up too. So build it in a way that's going to be maintainable by the whole team.
Thank you so much for your answer.
No worries. I see, Thomas, you put something in the chat. What kind of early warning signs that you've gone too far? Yeah. So I think for me, if you're specifically getting called upon when something goes wrong, is the first early warning sign, or at least a common one where, hey, we built some tests and automation, and it's not, hey, quality team, can you help me solve this problem? It's, Shane, I need you to help solve this problem. It means that either there's a communication error or some way that I've done it is indicating that I'm the only one that will be able to fix it. Or if it's your team, even your team saying, hey, I can't fix this, can you look at it? I think those are the early warning signs that something's a little bit too complex. I think if you have developers rerunning your tests over and over and over again without even reading the error messages, that's another sign. It's like, why don't they understand this? Have you built it in a framework that's so foreign to them that they won't even look into it? And they just assume that the test is bad, and then they just message you anyway. So yeah, little things like that where it seems like you've gone a little bit too far, because you start to notice people not being able to understand what you're doing and not being able to pick up the tooling. I think that's kind of what led to it with me. Yeah.
Awesome. Thank you very much.
Oh, good. Looks like we got another hand up.
Hey, thanks, Shane. You hear me okay?
Yeah, you coming through?
Great. So, yeah, thanks very much for the presentation. There's a few times in there where I sort of noticed, where I picked up a sense of like the same problem kind of appearing, and that was, we'd like to be able to test something, but the nature of the application and the way it's built makes it difficult or near impossible. Mm-hmm. And you were talking about shortcuts a little bit, and say, I think your example was, we can create a shortcut that gets, our test user logged in and into a location that lets us like perform the test that we really want to test. I don't really want to test the login, but it's it's a necessity. Do you have ideas about how we can make that better? Because from my experience, a big part of it is that the application, when it's being built, maybe developers are focused on like user stories and thinking about mm-hmm. user journeys and scenarios, and not really putting enough emphasis on like, okay, so how do we test this? It's like, yes, I understand when this goes into production and people are paying us, and how they're going to use it is probably going to look like this. But from a testing point of view, or to exercise things, like we need a bit more, because that is too limiting. Mm-hmm. How much of that is a factor in like these kind of situations, and is there something we can do about that?
Yeah, I think you brought up a great point there. And so the case is usually, yeah, you have siloed teams, like you have a development team, like you said, that's doing the user story for the customer, and they're focused on building that out. And then you have a quality team that's maybe doing the testing, there's no real incentive for the development team to build the application in a more testable way because they're not accountable for that. And they probably have tight deadlines. So if they do help you build out any of these shortcut APIs that are going to make testing more easier, I think you need to provide a lot of value behind that. And so I think that there's initiatives about shift left and moving quality around and all of that. But I think it's mostly just like, how can you get the developers on board with testing and testing in the way that you need to be doing the testing? And I've found a lot of luck like going to them and saying, hey, like, how would you like write this test? How would you do this? And like having them be part of the conversation when you're building stuff out, rather than assuming there's that brick wall there between you and the development team and being like, okay, well, I have to talk to my manager to talk to their manager, and then I have to provide some kind of business value. And I think with the shortcut APIs, like you can provide a business value fairly easily. You say, hey, it'll save 5 seconds per test. We have 100 tests. That's 500 seconds times the AWS cost of our infrastructure, or whatever you're using, right? You can do it that way, but I think it's always longer. And so if you use a standard testing framework that the developers understand, maybe in a language that they're familiar with, and you say, hey, it would be really cool to be able to do this, and work with them to like say, hey, how much can you do? How much can I do? I mean, on my team, a lot of us learned the backend coding language to write these like APIs ourselves to import them, which isn't always going to be possible. But when you're doing that, it's less like, hey, I need you to do this thing for me. It's like, hey, I'm wanting to learn about the work that you're doing and the code that you have. Can you help teach me? Can you do code reviews? And maybe that's your like entry point to get the developers and the testing team working together more solidly. That would be kind of my only advice. Did that cover kind of what you're after?
Oh, sure. I mean, all ideas are great. For me, I think it's a big part of it can be, I don't know, defining like what the acceptance criteria really is. And it's like, okay, yes, the user story has to be able to behave the way that, say, product owners want it to behave. And you have to be able to deliver like some sort of automation as part of the story, or I don't know, I guess I'm making an assumption on stories, but like your work packet, it's not, you're not done just because the customer can now use the feature. It's, you know, being done also means we have the ability to verify and check and write you know, automation hopefully delivered at the time of the feature, but like at least in follow-up, it's not just the user journey.
Yeah, exactly. Like including those developers in part of the decision around, what is it? Definition of done gets passed around a lot, but like having them on board with it from the beginning, we're going to build this feature and we're going to make it so that we can have these tests running to ensure that it stays stable and it's working. I think that's a great idea too. Yeah, getting them involved in signing off on, we're going to have all of this. Anyone? Any other questions? And anyone else written a testing framework, a custom one, and then left the company and had the team replace it right as soon as they left, or a couple of years later when it stopped working? It's only happened to me twice so far, so.
I had we have a product testing framework that automates the game side. I work for a game development company, a mobile app company. And so we have a framework or more of a monolithic system that kind of does a whole bunch of the different parts all in one. It's quite complex on the inside, but from the outside, you know, it kind of does all the things that you kind of want to do. It does device management, it does test reporting, it does test scheduling, and all those kind of things. And we had one developer maintaining it for quite a long time, a few years, right? And as soon as he left, it kind of started falling apart, and there wasn't really somebody that was an expert in it, and so we're at this point now where it's degraded so much that we need to replace it. Devices aren't devices aren't passing tests. Devices aren't even reporting anymore. The reporting of the actual infrastructure wasn't there in the beginning, so we really had no idea that there was a problem to begin with. We just saw tests succeeding, quote unquote, but nothing would be really reported. And on the flip side, the reports of the actual testing value, or like the pass fail of each step during that, would be kind of coalesced into a multiple pages of reports that kind of contradicted each other. So it was just a giant mess from beginning to end. And now we're at a point where we just have to scrap the whole thing. It was quite a large system too, but unfortunately we're at this point.
Yeah. Cool. Yeah. Thanks for sharing that.
Yeah.
I think one of the things to be cognizant of, like especially on the like development side, a lot of the development you're working will be refactored after a certain amount of time, right? That this was the best tool at the time, or like this JavaScript framework was king, and now it's like the worst thing that you could ever do. And so we need to, I think, get a bit better, sorry, at accepting that on the quality side too. Like, hey, we're building all these tests. We're going to have to refactor them at some point. Like, they're not going to keep working forever. It's not like we write a regression test at the beginning of the project and 4 years later, it's going to be the perfect regression test exactly that we need. And so I think there is some natural, like getting rid of an old framework and putting in a new one, because that's just part of like evolving as you go. But it's like, if you spend 3 years building a framework and then by the time you finished it, it's obsolete, then it's like, maybe you shouldn't have spent so much time on that and built something a bit easier that could maybe be upgraded.
Right.
Yeah.
Yeah.
Sergey. Oh, sorry. Yeah, keep on going.
Sorry, I just wanted to comment a little bit. They actually built it on top of their backend infrastructure for their game servers. So it has a lot of game specific code underneath that was never used. So they tried to reduce the complexity in the company by reusing tech, but that only kind of hindered and created more problems.
Mm-hmm. Cool. Yeah, Sergey, did you have something you want to jump in?
If it's working. Hey guys, hey everyone. My name is Sergey. Yeah, I had this exact situation with my previous company. I also built a really cool framework. It worked really well, and then it actually existed for 2 more years, and then at some point they had to switch to a different product. And I think I'm still very proud that it existed for 2 more years after I left. And my good friend actually stayed in the company, and he actually approached me. He's like, "Hey, Sergey, so we're demolishing everything you've built because no one understood what's going on." And unfortunately, it was kind of my first automation engineering kind of larger role. So it was my first big project, and it was not ideal. So I was actually surprised that it stayed for that long.
Nice. Yeah, thanks for sharing. Yeah, it feels like a common thing. And I'm not sure if the advice I gave in the talk is going to help anyone prevent that, but maybe it's going to prevent them going too far. And then when it gets maybe replaced or deleted or refactored later, that they didn't spend too much time. Or maybe it'll last 3 years. Maybe your next framework will last 3 years, Sergey.
I hope so.
Got a question from Sophia. Thanks for sharing your valuable experience. It seems like there are a lot of AI automation testing tools on the market. Do you have any experience with those tools? Unfortunately, no, I don't have any AI testing experience. But I think one of the key things, like I said earlier, is like looking at the tooling and seeing like common patterns in it and how it's being used by different companies. And whether that's like looking on the GitHub page, like it's not a good metric, but like counting stars or counting the number of issues, like GitHub issues that get open and closed instead of just it continuously being open. Things like that can give you a good indication of sort of where the rest of the industry is going. And yeah, maybe keep attending talks like this. Maybe if anyone in the chat has AI automation experience, speak up and let Sophia know, and like find someone who you can work with. I'm seeing some shaking heads, but yeah, I think try and find what the standard tooling is, try and use it as best as possible, understand why the tooling was built the way it is. And then if absolutely necessary, and you do need to build out some kind of custom tooling, just make sure you do it with the whole team involved, well documented, passed on to new people, spread the knowledge throughout the team, and try and make it as simple as you can so that anyone can come in and take over, rather than being stuck in the unfortunate position of being the subject expert of one person on a tool that's used across the whole company. Oh, Andrew, you want to jump in?
Sure. I actually, when you said about getting the whole team involved, in your experience, have you been able to do that like almost single-handedly, or is that more like you have to get like management involved to encourage? Because other developers and other development teams have, like we were talking about before, like they've got their own projects, they're trying to get their own stories done, that kind of thing. Like has individual charisma been able to encourage people to like learn about and like have input on these, like when you've had to do custom changes or custom work, or has it been, well, maybe a combination also of like getting management to get everyone on board and telling them, like roping them all together? Yeah.
Mm-hmm. Yeah, I think, and I mentioned it a couple of times now, like if you're using a standard tool, so for a lot of our API testing, we use RSpec, for example, which is a common Ruby framework that is used all across the web, super common. We haven't done anything super custom on top of it. And because of that, when we go and say, hey, developers, would you like to like help us by working on like helping us update some tests that need maybe refactoring because there was a big change in the way the application works or something like that. And you say, it's all written in a standard library that's like used by thousands of people, and it has good documentation, and there's even like there's Udemy courses that you can like go, and we took a couple of people like through Udemy courses, and all of the new quality engineers are going through that as well. And it's like there's all these resources out there that we can say, hey, help us out, and we're using the most standard thing or a really standard thing that you can look on Stack Overflow if you can run into problems, and it makes sense, and the IDE helpers are out there and all of the different things. I think that is a better sell than, hey, we need you to write these tests, and I wrote a README. It might not be up to date. There are a couple of bugs we don't have time to fix right now, so avoid this area of the thing. You know what like? It's just a better sell. As far as getting them to do it when they have a lot of stuff on their plate, I think that's always going to be tough. That's always going to be hard. I just think it's an easier plate to get them to at least look at if it's simple, easy to understand, not too complicated.
Thanks. Thank you. Yep.
I have a question.
Oh, we got one from Jen, and then I'll grab you next. Jen says, since it often takes a long time to complete a test automation repo, how can the test automation team demonstrate their contribution and convince the development team in a short period of time? How can the automation team? I'm not sure exactly what you mean. Do you mind clarifying, like, are you asking, is it how to convince developers to help out with automation, or is it Yeah. Okay. So how do you convince developers? So a similar sort of question, like how do I get my developers to help? So yeah, the tricks are sort of, yeah, write it in the language that they're already using is a nice little trick. It's like, hey, it's already this code. You mentioned test automation repo. Is there a way that you can put it in the repo with their code, like right next to their code? So it's right there and they already have it on their machine. So when you're like, hey, can you help out with these tests? You already have them checked out. They're right there. There's this simple standard command, like if it's a JavaScript, for example, npm run test will run them for you. Then they're like, oh, that's not too hard. I know all of that. Yeah, sure, I'll give it a go. And then they're like, oh, cool, thanks for like helping out. Yeah, we're having this problem with this test. Can you take a look at it? So I think it's finding those inroads. But yeah, it's kind of tough. It is really dependent on your organization structure too. If there's like the development team waterfall and throws a build to you and you have 3 months to test it, and then it goes through management and all the way back down, it's really hard for you to break down those walls. I think it's just you need to start saying, hey, if we built this in this really like hard to use way and complicated way, we don't need the development team's help, but it's going to be 50 extra hours to develop it, or 3 extra weeks on us getting these tests done. If the development team helps, we think we can get it done in 3 weeks less. And that's some kind of value. So that's kind of the management angle. It's like, we're saving value, we're saving time, this will be more efficient. And then the developer angle is like, hey, let's build some cool stuff together. Let's do it in a like developer friendly way as much as possible. Okay, and then I think Sergey was next.
And just to add to those, I think one of the valuable things is to show that your product actually brings value by catching bugs, and maybe not pointing that one team or one developer did something wrong, but like weekly or daily reports that shows that you actually catch bugs and provide value. I think that's also could be seen as a product that is worth investing in. And my question was about the situation. How do you approach it, for example, when a group of developers have strong opinions about going in one or the other direction that is different from yours in terms of automation? Since like there in many companies, there are teams who work with different technologies, different languages. And for example, one team who promote, for example, a Python-based framework, but you think that a different approach should be taken. How do you handle those situations?
Yeah, it's usually around coding languages too. Developers get really passionate about that. I think you've got to find the common ground there, and quite often the common ground is, do we want to catch bugs before the customers see them? And you sort of start from there. And the answer is yes. And then it's like, okay, well, now we have a certain amount of time in order for us to do testing and do automation before this feature is going to get released. I have the skills to do it in using this tool. You're saying that you want to do it in this tool. How much time can you provide? And like, where's the compromise? Like, is my tool going to be able to get us where we need to be, and you're able to support that, and you recognize that because I'm doing the majority of the work, I should have more of a say on the tooling? Or is it going to be something that you're willing to train me in the tooling that you want to use? And are you going to help maintain it? Because for me, if a developer's like, hey, if you write it in the framework that we're already using, and we'll help you maintain it, and we'll help you make sure it's running, and if stuff starts failing, we can debug it while you're off on holiday in Hawaii. To me, that's the golden sell for me. I'm like, okay, I'm willing to compromise now because you've offered all of that. And so I think, yeah, it's always going to be finding the compromise, but it's like, go back as far as you need to like, hey, what's the end goal here of the project? Find out where it affects them. And quite often people have super strong opinions, but then if you say, hey, well, are you going to do the work? And they're like, well, no. And it's like, well, you just lost your strong opinion, because if you're not going to be doing any of the work in this framework, then you don't get as much of a say. Yeah, Jen, that's a good point, that in Agile, it feels like the test team is always trying to catch up. Yeah, we're trying to be better at that, but I mean, it's one of the realities in life that you can't really test the thing until it's done. Like, you can start testing it early, but you're just gonna find a bunch of bugs if it's not finished. So yeah, difficult to find out how to do that. And I think, yeah, one of the other things I've had success with is asking developers what tests they want to run. Which you don't really think of. It's like, as a quality team, you're like, let's run all the tests all the time and make sure we catch all the bugs. But if you ask the developers, like, we have tests that run in regression overnight, and then we have tests that block your PR from being merged. And then we had some tests fail in regression, and then we came into the developers and they're like, oh, I think that was maybe my change. I don't know. How do we know whose PR broke the test? And you're like, well, they run in regression. It's separate from that. We don't know. Do you want me to add them on your PRs to block them? And they're like, yeah, no, that'll be great. And they're like, okay, like, let's come up with a plan so that they run and that they're stable and that they block your PRs. And if they're willing to opt into that, then you've already like started that communication, and then you can have those tests. Maybe the developers care about them enough. They're like, yeah, block me if I break this. Okay, well, now you need to know how it works, because if it blocks you, you need to be able to unblock yourself, because we're not always going to be right there to help you. And so that's a good way too. And then if the developers come back and say, hey, I don't want to run any tests, that's when you kind of hold up the quality card and go, whoa, 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 no, we're going to run them at some point. You either run them now and it tells you the exact PR that broke them, or we run them tonight and we tell you tomorrow morning that you got to roll back all that code you just worked on. So yeah, well, that's another way to like kind of talk with developers, just sort of ask, hey, when do you want these tests running? Do you want to run them on your local, on a PR, in the pipeline, on a staging environment? Like, where do you think is the best place to run these tests? Let the devs know the value of the test. Yeah, for sure. That's where Sergey's point comes in, where you tell them, hey, we caught these bugs, like this framework's catching bugs and it's doing good work. But yeah, proving the value of the tests for sure. The flip side of that too can be sometimes developers are like, oh, we have an integration test that covers this. And then you're like, oh, okay, well, let's find the happy middle ground there. Or they have a unit test that covers most of it. And it's like, come to an agreement, like maybe we can write a few less tests because we know that the unit and integration tests are covering that area really well. Yeah, Adam, that's a good point too. Reduction of bugs. Another metric we use is number of like customer support tickets. Like if we see that go down, especially around certain features, and you can attribute that back to test catching bugs. That's a good one as well. Lots of fun metrics. We got a hand up. Macon, is it?
Oh yeah. Can you guys hear me?
Yeah, we can hear you.
Yeah. This is my opinion regarding the Gen Chain question that you guys are talking about. For example, in my company, we have a kind of disagreement between the teams. Then every PR for new code to the main branch or master branch, then every developer should write a unit test, and thus in these unit tests should achieve at least 80% of the coverage. Then in this way, you start to introduce and spread the test culture among the teams. Then is the first step into, maybe in the future spread more another layers of tests and ask for developers to write more integration tests, white tests, something like that, using Sonar as your co-worker to show up the errors into the PR, something like that. I think it's a pretty good way to start ask for developers for any help as well.
For sure, test coverage can be helpful. It can also be a curse if you're talking about like end-to-end testing, and it's like how much coverage is on the end-to-end testing versus on the different layers. And we get into the test pyramid, which I don't want to talk about today, but definitely a subject for another day. But yeah, at least you know the developers are doing some testing, right? Like you've got some gates in place, and hopefully they see the value in that. Hopefully they're not just, I have to hit 80%, let's do the easiest 80% and then like call it a day. Hopefully they're seeing the value in those tests and doing them as well as they can.
It's a good point when they see a kind of the error in their PR, definitely you ask for help. It's a good point. Yeah, this is it for me, guys. Thank you.
I think we'll just do like a last call for any questions, comments, stories you want to share that you can relate to. And then we'll wrap things up after that. All right, well, if there isn't any other questions or comments, I think we'll wrap things up for today. A really big thank you to Shane for taking the time to join us today. Round of applause. It sounds like definitely a lot of people can relate to the things you shared and, gained a lot of insight. Oh, sorry, Chong, you had your hand up there. Did you want to jump in?
I pressed the wrong button. No, I pressed the wrong button. Sorry.
Oh, so you don't have a question? No, all good. Yeah, so again, just a big thank you to Shane. And thank you everyone for joining us for another great session of VanQ. And then like I mentioned at the beginning of the session, in case you missed it, we are still looking for a speaker for May and June. So if you are inspired now from Shane's great talk and want to come join us next month or in June, please reach out to me, or if you know someone who would be a fantastic guest, that'd be much appreciated. And then we can kind of keep these great conversations going and share lessons and stories. So I really appreciate that. So again, thank you so much to everyone. I will have the recording up on the VanQ meetup site probably tomorrow or so, or early next week. So look forward to that. So if there isn't anything else, thank you everyone, and then enjoy the rest of your night.
Thanks everyone.
Thank you all.